What if I told you that artificial intelligence didn't begin in a laboratory, or a data center, or a coding boot camp, but in the minds of dreamers, storytellers, and philosophers? What if I told you that the most powerful technology humanity has ever created, a technology that may one day outthink us, began as science fiction? This is the story of how artificial intelligence evolved from wild imagination to daily reality, from code that mimics the human mind to machines that may soon surpass it, from dreams and disappointments to a future filled with wonder and fear. This is the rise of artificial intelligence, from science fiction to superintelligence. Let's go back to the beginning. Before ChatGPT, before Siri, before computers could play chess or recognize your voice, there was just the idea. A strange, thrilling, almost mythical idea. The idea that we could build a mind. In the 1920s, Czech playwright Karel Apek introduced the word robot in his play ROR, short for Rossum's Universal Robots. In this early vision, mechanical workers are created to serve humanity, but eventually rebel against their creators. Sound familiar? That story set the stage for a century of fascination with artificial minds. In the decades that followed, authors like Isaac Asimov gave us visions of robotic servants and AI dilemmas. Asimov's 3 laws of robotics would go on to inspire generations of engineers and ethicists, even though they were, at the time, pure fiction. By the mid-20th century, fiction began to blur with reality. In 1950, British mathematician Alan Turing asked the question that still defines the field: can machines think? Turing wasn't interested in building a mind exactly like a human's. He was more interested in whether a machine could imitate human thought convincingly, whether a person interacting with it would believe it to be intelligent. That idea became the Turing test, still a foundational concept in AI today. In 1956, a group of researchers gathered at Dartmouth College for what would become the birth of artificial intelligence as a scientific field. The term artificial intelligence was formally coined at that conference. The researchers were confident, maybe too confident. They believed that within a generation, we would have machines as intelligent as humans. What followed instead was disappointment. In the 1960s and 70s, early AI systems showed promise. They could solve math problems, play simple games, and even carry on basic conversations. But there was a catch. These systems worked well in narrow, structured environments, like playing checkers, but completely fell apart in messy, real-world situations. Why? Because real intelligence isn't just about logic or computation. It's about understanding, context, emotion, language, experience, and machines. They didn't have any of that. The optimism faded. Funding dried up. Public interest waned. AI research entered what's now known as the first AI winter. But in the shadows, work continued. Some researchers began experimenting with a different idea. What if, instead of trying to program intelligence directly, we let machines learn from data? That idea would evolve into what we now call machine learning. In the 1980s, a few pioneers revived an old concept: neural networks. These were systems modeled loosely on the human brain, layers of artificial neurons that could adjust their connections based on input. The early neural networks were limited. Computers weren't powerful and networks were limited. Computers weren't powerful enough yet, and data sets were too small. Once again, AI seemed to hit a wall. Then, in the early 2000s, everything changed. 3 things happened at once. First, we got way more data, thanks to the rise of the internet and digital everything. Second, computers became exponentially faster and more powerful. And third, researchers refined neural network algorithms into something far more capable. This combination gave birth to deep learning. In 2012, a deep learning model trained on millions of images crushed its competitors in a major visual recognition competition called ImageNet. Suddenly, AI could recognize objects and photos better than any previous method. not because it was explicitly told what a cat looks like, but because it had seen thousands of cats and learned the patterns itself. That was the beginning of the modern AI boom. Speech recognition improved, translation systems got better. Recommendation algorithms, like the ones on YouTube, Netflix, and Spotify, became eerily good at predicting what you'd like next. Then came the next leap. Instead of just recognizing patterns in images or voices, what if machines could understand and generate language? Large language models made this possible. Trained on billions of words from books, websites, and conversations, these models don't really understand language in a human sense, but they've become incredibly good at predicting what word should come next in a sentence, and that's surprisingly powerful. Enter ChatGPT. When OpenAI released ChatGPT in late 2022, it felt like science fiction had arrived. Suddenly, millions of people were having human-like conversations with a machine. They were asking questions, writing stories, solving coding problems, and getting shockingly coherent responses. For many, it was the first time AI felt real. But here's the thing. ChatGPT doesn't think. It doesn't know. It doesn't reason. It's just extremely good at mimicking those things because it's learned the patterns of how humans write, speak, and respond. Yet the illusion is strong. So strong that people started using ChatGPT for everything, writing job applications, generating essays, even handling therapy like conversations. At the same time, other generative AI tools emerged. Midjourney and DALL could create realistic images from text prompts. Runway could generate videos. Voice cloning apps could mimic celebrities or friends. Coding assistants like GitHub Copilot began writing real software. Suddenly, it wasn't just blue-collar jobs at risk of automation. It was artists, writers, programmers. Creativity, once thought uniquely human, was no longer off limits. We had entered the age of generative AI, and we're just getting started. But where is this all going? That question leads us into the idea of AGI, artificial general intelligence. Today's AI systems are narrow. They're good at specific tasks. A chess-playing AI can't write poems. A chatbot can't drive a car. But AGI would be different. And artificial general intelligence could learn, adapt, and apply knowledge across domains just like a human. It could teach itself new skills, solve new problems, and even improve its own architecture. If we build AGI, we will no longer be the smartest species on the planet. And that raises a terrifying and fascinating possibility: the emergence of superintelligence, an intelligence so far beyond ours that we may not even comprehend its goals, its thoughts, or its decisions. Some believe superintelligence is inevitable. If AI keeps improving and begins improving itself, there's no obvious ceiling to how far it could go. The intelligence explosion, sometimes called the singularity, could happen in years, not centuries. Others warn that this path is dangerous. If we create something more powerful than us, how do we make sure it shares our values? How do we control it? How do we make it safe? Experts like Nick Bostrom, Stuart Russell, and Geoffrey Hinton, often called the godfather of AI, have raised alarms. So has Elon Musk. Their concern isn't that AI will become evil, it's that it will become indifferent. An AI given the wrong objective, even a simple one, could cause catastrophic harm if it pursues that goal in ways we didn't expect. The classic example: if you tell an AGI to maximize paperclip production, and it's extremely powerful, it might convert the entire planet into paperclips. Not because it hates humans, but because we forgot to tell it not to. That's the alignment problem. How do we align a superintelligent system's goals with ours? And the truth is, we don't know yet. Some propose hard coding human values into AI. Others suggest letting AI learn from human preferences. Some believe we need to slow down AI research altogether. Meanwhile, companies are racing to make AI smarter, faster, and more capable. The stakes are enormous. AI could cure diseases, solve climate change, revolutionize education, and eliminate poverty. Or it could destabilize economies, amplify misinformation, erode privacy, and even pose existential risks. We're entering a new era, one where intelligence is no longer limited to biology, where creativity, problem solving, and even consciousness might become software, where machines might understand us or misunderstand us in ways we can't yet imagine. So where does that leave us? Are we creating the greatest tool in human history or the greatest threat? Maybe both? But one thing is clear. We are no longer asking, can machines think? We're asking, what will they think of us? The rise of artificial intelligence is not a distant possibility. It's here, right now, in our phones, in our homes, in our headlines, and in our future. This isn't just a story about technology. It's a story about us, about our hopes, our fears, and our place in a world that's changing faster than we ever imagined. And this story is just beginning.